The following is a demonstration of reflectance transformation images that were taken at the request of the San Diego Natural History Museum of some bone fragments. These are to demonstrate the use of this particular technology, which involves taking many different pictures at different light angles and then using a mathematical algorithm to capture and process into one image all of the data about how the light is reflecting off the surface, and in this way a surface texture map is created. Notice that the icon I have is a little flashlight, and it simulates the idea that if one had this bone in one's hand, one could take a flashlight or any other kind of light and move it around and look from any light angle. And that is indeed what we are doing with a digital image on the computer. One can also do such things as use enhancements. This one is called diffuse gain. It enhances a little bit the data so that one can see the cuts that are made in the bone much more clearly. Another possibility is to use two different lights to set up a situation in which the user can use one light as their main light and the other light as a fill. And in this way, the cuts that are made in that bone become very distinct. Another example is where a bone is thought to have been used with a saw. And notice that as this image loads, it takes a few seconds. It's quite large, and both color and interactivity data are being loaded. Let's zoom in a little bit. And again, using this little flashlight, I can look around, move the light around, look at it from any direction, and see the enhanced surface detail. Again, let me try two lights, see what that looks like. And what's really good about this is that it's always the user, the one who wants to study the image, who has control of how it is lit. And in this way, move the light precisely where it shows the most detail. There is also the possibility of using something called specular enhancement. Specular enhancement makes it look like an object has been dipped in silver, and that can sometimes also be very helpful in bringing out surface detail. At all times, one can control the amount of light, make it more, make it less, really adjust the image to where it shows the data to the best effect. And then finally, a bone sample in which it was possibly trampled. Again, move the light in any direction. I can also control everything from this thumbnail on the side. And again, I can see the surface texture. Let's try it with that diffuse gain and see if we get any more detail. And we can see that that does enhance the marks on the bone. And we'll also try specular enhancement. perhaps a slightly less effective. It works less well on curved surfaces than some of the other enhancements that we can use. So let's take those off and also try again dual lights. You can see that it is very important that this gives control to the person who is actually studying the image and not to the photographer. There are a couple of other options. One could use, it's called a spotlight. One can move around. Just looked at selected areas. Or local light, which shows a broader range of data but does allow you to highlight certain aspects of the image. We are hoping to do many more samples for the San Diego Natural History Museum that will show the utility of this particular technology for the study of bones and other natural history objects. Thank you.